Okay, so welcome to this NPTEL course live stream event on dynamics and control. Okay, so my name is Ashitava Ghoshal. Okay, so I hope I am audible. I can see one Shravan Kumar. Shravan Kumar, am I audible?
Yes, sir, you are audible, sir.
Okay, good. Where are you from, Shravan Kumar?
Sir, good evening, sir. Myself, Dr. C. Shravan Kumar. I'm working as assistant professor at SRM University, Chennai, sir.
Okay,
Department of Mechanical Engineering.
okay, wonderful. Okay. So, since you are the only person other than the TA, Pramod Kumar, who is there, so maybe you can tell a little bit about yourself. Maybe if you have any questions, if you have any suggestions, or if you have any comments.
Yes, sir. This is the first time I'm doing this course, sir. Actually, I have done my PhD from IIT Guwahati
Okay.
in the field of condition monitoring, vibration-based condition monitoring. So, under the supervision of Professor Rajiv Tiwari, sir.
Okay.
So after that, it's been 2014 I completed. So
Okay.
I'm in teaching for the past years. Sir. So almost like around 10 to 11 years. Sir. So now here we have our MTech robotics stream is there. And so actually I'm trying to develop the course for kinematics and dynamics of robots as well as for control of robots. So
Okay.
I have taken this course for last 2 years, but your NPTEL course I have registered it this time only. So I
Okay.
found it really useful, and I've gone through till 4 weeks. Uh, and actually, I felt that you are giving like in-depth, like every explanation and clarity is there, so we are able to get about the concepts.
Okay.
So you can give me some guidance as to how further I can implement for our MTech students. So any guidance regarding this, and also like how to prepare for the exam. So maybe regarding that you can tell us.
Okay. Okay. So let's start with the exam part. Just give me a minute. I will try to write something and I will share something on the screen. So just give me a minute. Huh?
Okay, sir. Okay, sir.
Okay, let me see if I can share. Okay, good. So can you see my screen?
No, sir. No.
Huh?
I can see, sir. It's a blank page.
It's a Word page.
Yes.
I'm writing. So welcome. Can you see this word I am writing?
For me, it is visible.
Shravan Kumar, can you
Yes, sir.
see?
Yes, sir. Yes, sir. Welcome you, everyone.
Okay, good. So I will show other things also, but I thought I will just test this. So So exam, okay? So the exam is basically MCQ or MSQ. So there'll be 50 questions. Okay, each one of them will be 2 marks. Okay, so this is important. There will be no subjective type questions. Although in the assignments, you will be seeing some subjective type questions.
Okay,
So
sir.
it's only MCQ, MSQ, and 2 marks each.
Okay.
And what I'm told, and I'm following NPTEL instructions, okay, more than 50% are from assignments. I think 60%, if I'm not mistaken. Okay. So if you want to do well in the exam, you should do the assignments.
Okay, sir.
So there are direct questions from assignments, and we have to follow the rules of NPTEL. So direct questions means not that exact the same questions. You know, the order can be changed, choices can be changed, or maybe somewhere I have to ask you to do some calculations. The numbers can be changed, but the rest of the question will be exactly same.
Okay, sir.
So 50% are from there. There'll be some questions, if I'm not mistaken, some maybe 15% are slightly harder, trickier questions. Another 15% are from the lectures. Pramod, do you remember the breakup? I think some breakup is like that. Okay. So if you look at the NPTEL website, they will tell you.
Okay, sir. Okay.
So I think it's 60, 20, 20, or maybe 60, 15, 15, 10, something like that. But majority of the questions are from the assignments.
Okay,
Yeah,
sir.
correct, sir. Majority is from assignment and like very less from very like out of the box questions.
Out of the
Okay,
box,
okay.
how much are there?
Like 10% or very less, yeah. 10 or 15%.
Yeah, 10 or 15%. So those 10 or 15%, you have to think. Basically, you have to understand. It is not as if it is outside the course or syllabus, but it is not straightforward. You have to think a little bit.
Okay, sir. Okay.
So that is as far as this is concerned. And then your first question was about what to do, okay, for your courses. So I don't know. Are you aware that there is another course which I teach called robotics?
No, sir. I have not gone through it.
Okay. So there is another course which is robotics, which is also an NPTEL course.
Okay.
Okay. So maybe you can take a look at that. So
Okay,
if
sir.
you type robotics and maybe my name, Ghoshal, you can see, old. I think it's available also on YouTube.
Okay, sir.
It is too late to register for that course.
Okay.
It is also running this time from January
Parallel.
onwards. Yeah, it's a parallel one. But you can always take a look at it.
Sure, sir. I will go through it.
Yeah, so only difference is, so there are many robotics courses. I'm sure you know in NPTEL and various other places. Coursera is there, SWAYAM is there, all kinds of robotics. Robotics is very popular, no?
Correct.
Everybody wants to do robotics. So there are many such courses. So you should take a look at the course which I am giving, okay, is a slightly more advanced.
Yes, sir.
Slightly.
Yes.
Not a whole lot advanced, but it's a little bit more advanced, meaning that this is more mathematical.
Yes, sir. Yes.
Okay.
Here also, I'm trying to develop the syllabus for kinematics and dynamics. That was why first place I took your course,
Ah,
so that I'll also be well, get more into the concepts and.
ah, 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 ah.
Mm.
So, yeah, so you can see in this course on kinematics, we talk about rigid bodies, we talk about connected rigid bodies, all
Serial and
kinds of things are there.
yes, sir, it is right.
Velocities, acceleration.
Yes,
So
sir.
it is not a theory of mechanisms course. So, in
Ah,
some of these uh, places you have TOM, theory of mechanism course. So this course is not like that. There
yes,
are
sir.
also some very well-known courses on theory of mechanisms. Okay, so if
Mm.
you want to talk about four-part mechanism and analysis and synthesis of four-part mechanisms,
Advanced
and
kinematics,
yeah,
I think.
advanced kinematics.
Mm.
So there are many courses like that. So this course is not that. This is a very, I would say, reasonably basic course on dynamics and also on controls. So so in ISC, we take this. This is a compulsory course for all master students. Used to be, I don't know right now what
Okay,
it is.
okay. Mhm.
It's a compulsory course. It basically there are many students coming from different colleges, undergraduate colleges. They would
Mhm.
not know some of the topics.
Mhm.
Okay. So, for example, they were I don't know. Do you teach Euler angles in your college?
Yes, sir. Yes, sir. For this course, I have included it, sir. No, but not for the other. In engineering mechanics and all, we don't.
Correct. Okay. So many students, many colleges will not teach what is Euler angles. Similarly, do you teach Lagrange formulation?
No, sir. No, sir.
So this is some of these topics are very important for. So this is like no, not many universities. I know some of the IITs teach it, but
Yeah.
maybe some engineering colleges will not teach. So
Yes,
the
Lagrange formulation, like I remember, I did it for advanced like vibration course. I had it. It is similar to that. So that I have included in here also syllabus Newton Euler and I saw in your course also, sir. So Newton Euler and Lagrange I have included it. I think other you mentioned the Keynes method or
no, that is not taught.
that is
That
not
is
there.
much
That is
harder.
not.
Yeah, it
Okay. Okay.
requires a lot of preparation. So you need to actually Keynes formulation is mostly for graduate students, MTech students. It is
Okay.
not for. So this course is for either senior, third year or fourth year UG student or first year MTech students.
Yeah, first year MTech students. Okay.
Yeah.
Okay, sir.
So because it is, but Keynes formulation is,
Yeah.
I think it is much harder. It's also very useful, but it is much harder.
Okay, sir. And sir, just one more doubt I had, dynamics and control. So should it be taken as a single course, or we can have kinematics and dynamics as one and control as a separate one, sir?
Yeah,
Just a suggestion.
yeah, this is a question which I've heard many times. Okay, so
Okay.
the thing is, you can do both ways. The kinematics and dynamics, and maybe some programming, and maybe some MATLAB type of thing can be one course, and then controls can be another full course. So again, the motivation for this dynamics and control is that in ISC, the students coming from after many places, they wouldn't have done any course on control.
Okay.
So it is not a compulsory course for many mechanical UG students.
Yes, sir. Usually, I think it is in electives.
Yes.
Mostly it is in elective.
So this course was meant as a bridge course. So students coming from somewhere who have not heard of, let's say, PID control, or they don't know what is frequency domain or state space, okay,
Yes, sir.
approaches. So they wouldn't have even heard of it. So for them, this is like, in some sense, little bit introductory, but I am hoping that all the main ideas are there and some problems are there, so that if you work out the assignments and look at the problems which are done in this course, so it will help. So if
Sure,
you
sir.
go towards the end, you will see that we take the same problem using root. You are aware of root locus, no?
Yes, sir. Root locus stability.
Yes. So root locus based approach, then frequency domain approach, and then using state space. So you will see the same problem has been designed using all these three ways. So just to give you a flavor of that, there are things called different approaches for controls, and you can use them. You get the same result. Sometimes it is easier in one, sometimes it is harder in that one, so on. And the other important thing why this is together is the state space approach is very, very follows nicely from dynamics. Okay, so if you know dynamics properly, if you can derive the equations of motion, let's say for the robot, then you can very easily use state space approach to design controllers for a robot.
Okay, sir.
So that's why it was put together. But yes, you can keep, but if you want to separate it out, you have to add something to the kinematics and dynamics part, maybe design,
Okay.
synthesis, okay? Or if you want to add in dynamics, you can add vibration, okay? And in control also, you need to add something. So you can add a lot more about classical controls.
Okay, sir. Okay. Fine, sir. Okay, sir. Sir, one common question I get from the students, like last time I started the course, so sir, it's full of mathematical, more of mathematical, more of
Okay.
mathematical. So, can you tell us like some real-time applications of this? So this is the common question I get.
Okay.
So I try to give some examples, but some suggestion from you, I can motivate them better.
Okay. So if you look at the course material, no,
Yes, sir, yes, sir.
if you look at this, let me just try to get to that page. So, okay, so have you seen this slide?
Yes, sir, yes, sir.
So these are some applications. Okay, so for example, this is a robot which the TA which is there, Pramod, he works on something similar.
Okay,
So this
okay.
is a robot which it can walk back and forth, and it can twist, it can turn. Okay, so this is an example of a robotics application. Okay, then this is another example of control. So this is the 2 degree of freedom. So these are two links. One link is top, one link is bottom. And suppose for some reason I want to go this up and down. Actually, this is the leg of this robot.
Okay.
Old robot. So if I want to do the control of this leg, I have to first control this. This is another one, which is another work of another student.
Yeah, the solar.
Yeah. So here, basically what you have here is, I'll stop it, I'll freeze it here. So here, what you have is this mirror, because this is the back of the mirror. And what you can do is you can tilt the mirror about one direction, which is elevation. means you can take it up and down in the sky, okay? And then you can have something called azimuth. So this is an azimuth elevation control or motion. Okay, so you can track the sun going east-west, and also you can track the sun going a little bit north-south. During summer it goes south towards the equator and north, it goes to the
towards in
tropics.
summer it goes towards north.
Tropic of Cancer, and then during winter it goes south.
Towards the south.
Yeah. So you can do this tracking using these two motors and this mechanism. This is the serial mechanism. This next one is a parallel robot, which you can also do. So there are many such examples, okay, of where you need the kinematics, where you need the dynamics, and where you can design controllers such that you can get whatever you want. So
Yes, sir.
this is one of the first slide. There are many other slides. You can,
Okay,
if you
sir.
want, you can go through the other slides which are there,
Okay, sir.
and then we can. Let's see where else. Pramod, do you remember where else we have some nice videos?
What, sir?
You have some videos of applications.
This one was there. One Euler angle was there, I guess.
That dice one I have seen, sir. That's also very good, sir, actually.
No, but actual practical application.
Yeah.
I think it is one of them is here, if I'm not mistaken. Okay. So this is a if you have this Lego kit, no, you can show it in your class. So for example, this is a model of what is called as an inverted pendulum.
Inverted pendulum. Okay. Nice, sir. Nice.
So you can see this video. So you can see that it is, while going back and forth, you can balance this inverted pendulum.
Okay, sir. Beautiful, sir. Beautiful.
Let me see. This is another one. So this is another student in the lab. So what he is doing is, so this is the motor, and this motor has a small, like a link. It will show you when it is in one direction, and then when you rotate it, you can see it rotating.
Sorry, sir.
So this is a motor. You can see this motor, no? You can see my cursor.
Yes, sir. I can see the motor and that link also.
Yeah. So what he's doing, what this other student is doing, his name is Yogesh. This is like some kind of a plate, okay, with some Arduino controller. And if you rotate the plate, this link will also rotate.
Okay.
So you can see.
Yeah. Something like a joystick, huh?
Yes. So what he's showing you is that I can control the motion of this motor. So there is some measurement is going on, there is some actuation is going on. So you can control the motion of this rotation of this motor by this. Okay. And this is where we wanted to apply. It was not fully successful. So this is a cart. Okay. And in this cart, so this is like a two-wheeled vehicle. Okay, so there are this one wheel and there is another wheel at the back. So it can go on the road, but then if there is some noise or disturbance, there is something which is at the base. So I will show it to you. This is the controller. This blue thing is the motor and the controller. Something will move on the rails. So if it is falling down, then you move something to the back so that it straightens. So the same algorithm which was shown here, that rotating the plate, okay, is used here. So it is trying to move it on a slide such that that base is always horizontal.
Mhm.
So you can think of this like a like a cart on the road, and then it is going over bumpy road, and then it will try to keep it horizontal.
Mm. So it tries to keep it in a stable position.
Yes, yes. Horizontal. The stable desired position is I want to
Horizontal position.
horizontal. So suppose, so just to thought experiment that suppose I'm carrying some liquid on a cart, and then
Yes.
this cart is going over the road. There are all these bumps
Yeah,
and
yeah.
up
Okay,
and
okay.
down. But I
Yeah,
want the liquid not to fall, not to spill.
to fall
So
down.
then you have to move this base platform up and down, sideways, along the length, such that it is always horizontal.
Okay, okay. Sir.
The same thing here. So the student is moving this. So you can think of this as the base, and this is the motor which will move this back and forth. So here also, as you are rotating the plate, it will move this back and forth.
Nice, sir. I see.
So there are many such examples. If you look at my website,
Okay.
there are many, we have done quite a bit of projects. Not everything, but some of them are mentioned there. And
Yes,
if
sir.
you look at, so this Pramod Kumar, the TA, he works in something called as a Robert Bosch Center for Cyber Physical System.
Okay, sir. I think you mentioned in your video regarding
Yeah.
that.
So he works in this. You have all kinds of robots and various other things which you want to control. So these are some of the simpler ones. This is a two-link robot. This is a sun tracking. This is, of course, not very simple. This quadruped is not very simple.
Okay.
So it is lots of problems and lots of things which go into it to show that it can
Walk.
walk.
Sir, one more question, sir. Sir, while teaching forward kinematics, so currently I'm using the DH method, sir. So, so apart from this, any other methods or like you were mentioning about quaternions and all.
But yeah, so you can use, so quaternions and other things are only for the orientation part. Okay, so it is not for the forward kinematics as such. So there are many ways to represent the orientation of a rigid body. Quaternion is one of them. I think in this class I have used mostly Euler angles.
Yes, sir. Euler angles. Yes.
You can use whichever you like. Let me just see which one I have used. Yeah. So these examples, all these videos which you see for that, that dice. So they are all using, various kinds of Euler angles. So rotation about X, Y, Z, body fixed, space fixed, various things are there.
So rotation about some general K axis and some.
Yes.
I think that is more general, no, sir. That makes it more generalized.
Yes. So this is body fixed rotations. You can see this video. Or cannot play video. I don't know what it is. Okay.
Yes, sir. This video I saw in your lecture.
Okay. So quaternions is one way. In this, we have used mostly Euler angles.
Okay, sir. Okay.
Of course, you have to use this rotation matrix idea is always there, because with rotation matrix, that is the best, most general form.
Okay, sir. Sir, apart from for forward kinematics, apart from deep algorithm, what are the other methods, sir?
Forward kinematics is only the simplest is using transformation matrices, 4x4
Okay.
transformation matrices.
Homogeneous transformation.
Yes. Okay. You just multiply matrices, no? So then it is very easy to do
Okay,
whatever
sir.
you want. So yeah, nobody because it is so straightforward and simple, nobody has, and there are really no problems, okay, with forward kinematics, so nobody really worries about it.
Okay, sir. Okay, sir.
But forward kinematics and inverse kinematics, that is more for robotics. This is not for this dynamics and controls
Dynamic
course.
control, yeah, I understood. So from our for our course syllabus, just I asked that question, sir.
Yeah, sure. I mean, you can ask me whatever you want. If I know the answer, I will tell you.
Sir.
So how many students are there in your class?
There are 7 students.
Okay.
7 students. Sometimes we don't get students, sir. Last year, there were no students, and before that year there were students. So slowly we are trying to develop, sir. So the other part, we have a robotics lab, and they have the work space to develop all the Arduino kits, and also they have this ABB pick and place robo and other small manipulators are there. So they have some state of art facilities. I was when I joined, I didn't get involved into the robotics. Slowly they asked me to teach this course, kinematics and dynamics. So I started, and slowly we are developing the course, sir.
Very good. So you can see this NPTEL course.
Sure,
Okay.
sir.
So if you can't find it in NPTEL, you just go to NPTEL website and search robotics with my
Robotics.
name.
Okay, sir. Okay, sir.
You will find some courses there.
Okay,
So
sir.
as I said, it's a little bit advanced. It is not an introductory course, but there are other introductory courses also. So there is a course by one IIT Kanpur professor called Ashish Datta, and you may have heard of him. So his is a very basic introductory course.
Okay.
You can show it to the students.
Yes, sir.
There is
Okay,
also,
sir.
there is also somebody from IIT Delhi, Professor Subir Kumar Saha. He has written a textbook, and they have also some software. But those are all for in robotics.
Initially, I followed the first time I took the course. I followed Sponge and Vidyasagar book, sir. Later, in a conference, I met some professor from I think NIT Jammu, and he was working in the field of robotics. He suggested me Craig book.
Craig's book is much better.
Yeah, yes, sir. That is right. And one more thing is every book, the notation slight differences come.
Yes.
But
So
initially,
Craig's notation is, I use Craig's notation in my book.
Yes, sir, I saw that, sir. Yes, sir.
So there are inherently some advantages in Craig's notation. And if you want, we can discuss it some other time, because this is not the robotics part. But there are some inherently very big advantage, especially for some structured, what is called as a tree structured robot, or for parallel robots. That is much better than what is there in the Spong and Vidyasagar, or even in this book by Saha.
Okay, sir. Okay, sir. Okay, sir.
But thank you for coming.
Okay, sir. Thank you very much, sir. So it's really nice to discuss with you, sir.
Mm. So how do you find the assignments?
Sir?
Have you done the
Yeah,
assignments?
assignment actually, this was the first time I was doing. First assignment, I didn't know that the square box means multiple choices. Okay, so first I thought like one or two maybe. Then actually one of my friend told me that so if it is a square box, then you have to go for multiple choices. So then I have done it. So yeah, I was able to attend the question, sir. But first assignment was little. I had to think again or something like that. Second week and third week, I was able to do. So I followed all the videos. So fourth week, tomorrow is the deadline. Fourth week, I have to do. Assignments are fine, sir. Assignments are fine. Some questions we have to search again or we have to go through it again. But otherwise, I was able to do it, sir.
Good. If you find some mistake in the slides, you can send it to the TA. Or you can put it up in a forum. There is a forum, no?
Okay. Forum
For
in
this
NPTL,
course.
sir. Yes, sir.
Yes. For this course, there is a forum where you can
Yes.
put up doubts, put up questions.
Okay, sir. I'll check it, sir.
So some people will write. So it's like a discussion forum.
Okay, sir.
Or you can send the email saying that, oh, this looks like a typo or a mistake in the slide number such and such. So some people will comment on it. And even the TA can see what are the questions in the forum, and then they can put up the answers or discuss basically.
Sure, sir.
Pramod?
Hello, sir.
Yes,
Hello.
Pramod, did you check with NPTEL if they have given any offline questions?
offline questions. No, it is yet to come, I guess. Subjective
No,
questions, right?
Is there anybody from NPTEL here, NPTEL team? NPTEL IISc, you are here, no?
Yeah, they're here.
Yes, tell me, sir.
Yes.
Who are you?
I'm Bharat, sir.
Bharat. Okay,
Yes.
Bharat, were there any questions which were posted offline for this course?
Still not yet, I think, sir. I will
Okay.
talk with the office and update
Can you
you.
please find out?
Yeah, sir, I will.
Because so if somebody has given some question, then and Pramod, also you can check this YouTube live stream.
Yes, I'm checking.
You are checking, no? So
Yes.
if there is, I can't see that question. If somebody is asking some question, you can tell me.
Okay. Yes, I will. So there is no message yet.
Okay. Shravan Kumar, you said you are from PhD from IIT Guwahati, huh?
PhD from IIT Guwahati, sir.
Okay. You said 2014, huh?
2014 submitted, sir. 2015 awarded.
Okay. No, the PhD is from the day you submit, not from the day you get the actual piece of paper.
Yeah, Viva was in 14, sir.
Ah.
That
That doesn't matter. No,
Okay, okay.
normally the rule for PhD, which is commonly used everywhere, is so in your thesis,
Make
no, you would have said July 2014, or
Yes,
you
sir.
would have said some August 2014, no, some
Ah,
date, some month
yes, sir.
and year. That is the date of your PhD.
Okay, okay, sir.
So when you apply in resume, no, apply for job, you should say, because it is not your fault that these people took, let's say, 6 months or 1 year to review your thesis.
Okay, sir.
Everywhere in the world, the day you submit, that is your PhD date. Until and unless you did not get the PhD, then it.
Okay, sir.
Sir, Gurraj from NPTEL, sir. What is
Yes.
the question, sir?
No. I wanted to know if there are any questions in the online forum or any submissions
Oh,
for
okay. In Google form.
in Google form,
Okay, sir. Okay.
because I didn't get the Google form.
Sir, last year we visited IAC Bangalore for one vibration related conference, sir. Invest 2024.
Okay. Do you take part in this NACOM conference?
Sir, which one, sir?
NACOMM. NACOM. Mechanisms and machines, and also
I
robotics.
think this December it was there, no, sir?
December was IPROM. So
IPROM,
this
okay.
coming December, there will be a NACOM.
Okay, sir. Sir, can you spell that, sir? NA?
I'll write it down 1 minute. Just 1 minute. How do I write? It is INACOM. And I think I will try to search.
NACOMM.
Last time it was in Raipur, okay, 2023.
Okay.
So NIT Raipur. So now
2025 December, sir.
it at IIT Hyderabad. So
At IIT Hyderabad.
yeah, so if you
Okay, sir.
can you see my screen? I can.
No, sir.
Okay, I will share. Can you see the screen now?
Yes, sir. Now I am able to see.
Yeah.
Association for Machines and Mechanisms.
So this time it will be held in IIT Hyderabad. So please take part in this. So this is the.
Sure, sir. Sure, sir. Thank you for the information, sir. We'll definitely.
Yeah, this
participate.
one. This is the one. 7th International and 22nd National Conference on Machines and Mechanisms. So it is an ideal place for doing whatever you're doing in mechanisms and machines and also in robotics. So you have to submit the paper by July, full length paper.
Okay. Okay, sir.
Now you can see in areas of robotics, in smart structures and machines, in compliant mechanism, analysis and synthesis of mechanisms. All these areas are there.
Okay, sir.
Yeah, please pass it to your colleagues and
Sir, I'll forward it to our group, sir.
yeah. It's a reasonably good conference. And then some of the papers from that conference will go to a journal.
Hmm.
You can go to the website and they will tell you.
Okay, sir. I'll look into the details. Also, in my group, I will share it, sir.
And your friends, if you have somebody in some
Yes, sir. Yes,
other,
sir. Previous, other institutes also, we have some friends.
yeah.
I'll share it with them, sir. Earlier, before joining SRM, I worked at Amrita Vishwavidyapeetham for 1 year, sir.
Amrita, you don't have to advertise because one of the very important person in this NACOM, no, is from Amrita.
Okay, so I worked at Amrita Bangalore campus, sir.
He's also in Bangalore campus.
Okay, you maybe you are mentioning Rajiv Lochan, sir.
Yes, yes.
Okay, sir. At that time, he was doing his PhD. So, long time, I think in.
Yeah. So Rajiv Lochan, some
Yes, sir.
Chittavadi or Chitta, whatever, something like that. I don't remember his first full name. But he is the secretary of this AMM. So he
Oh.
certainly knows about this conference.
Oh, okay. I didn't know that. Okay. Then I'll talk to him once. A long time I didn't have contact with him, so I'll definitely look into it.
Yeah, good. Yeah, but if you have some friends in, let's say, where is your campus, SRM?
SRM Chennai, sir. SRM Chennai campus.
So you can,
here,
there is a VIT there, no? Is VIT
yeah,
nearby?
VIT is Chennai is also there, sir. Nearby, sir.
If you know anybody in VIT, or if you know anybody in that IIT DM Kanchipuram,
Yes, sir. Triple ITDM, I have some contacts, sir.
so just send them.
Okay. So there, actually, I think 2 years back, or I don't remember, sir. Triple ITDM Kanchipuram, they conducted one course on, like, online course on kinematics and dynamics of robo. So, like, I joined it. I couldn't attend all the courses because parallelly some accreditation work was going on. It was a nice one, sir. So in the starting stages, I attended that course also. Triple ITDM Kanchipuram. I'm not immediately getting the professor name. Sorry for that.
Okay. Are there anybody else? Pramod, can you see if there are any other participants?
No, sir. Like on YouTube also there is no one.
Okay. So this NPTEL team, no?
Yes, sir.
Maybe you should advertise a little bit, next one, no, when we hold,
Okay, sir.
please, send at least 2 emails to all the students. You
Okay,
have
sir.
their email ID, no?
Yes, sir.
So next time you just send once, maybe 10 days before and 2 days before,
Okay, sir. Sure.
so that at least the more people can attend.
If no question is there, we can wind up, I think.
Yeah, we can wind up. Shravan Kumar, do you have any
Thank-
other questions?
No, sir. Thank you, sir.
Okay. Okay, so thank you very much, everyone. Anyway, it was another only 10 minutes are left. But yeah, let's just thank Shravan Kumar and thank Pramod and thank the integral team. So I will close this meeting, okay?
Okay, sir. Thank you very much, sir.
Okay, thank you. Bye.
Bye, sir.